Students, in lesson 7.2, we are going to be working on multiplying fractions and a whole number. Our central question for our lesson is, how can you use a model to show the product of a fraction and a whole number? So we're going to start with an investigation. Martin is planting a vegetable garden. Each row is 2 meters long. He wants to plant carrots along 3/4 of each row. How many meters of each row will he plant with carrots? So what we're going to do is we're going to multiply 3/4 times 2. What we're going to need for this is our fraction strips. This is something that we worked on in class, but you can also draw models of these on your notebook paper if you like. So step 1, it says place 2 one-whole fraction strips side by side. So I'm going to draw your attention down here to seeing these two. I'm coloring them in red just so it reminds and prompts you of what we did in class. This represents the length of the garden. Step B, find 4 fraction strips all with the same denominator that will fit exactly under 2 holes. So when we look at the denominator here, we see 4. So what that means is that we need 4 pieces to fit underneath our 2 holes. And we know that the only fraction strip that would be the case would be halves. So what we're going to do is we're going to place a half under each of these. So this is 1 half, 2 halves, 3 halves, 4 halves. And on the side, I'm just going to write here that each of these represent a half. It's a little too small. I can't write all of those in. So what we're going to do is we drew a picture of our model. And now we're going to go on to our next step, boys and girls, where it says circle 3/4 of the 2 on the model that you drew. So we check, we see we have 1, 2, 3/4. So 3 out of the 4. We're going to circle the 3 out of the 4 that we circled here and we drew. Now it says complete the number sentence. 3/4 times 2 would be 1 half, 2 halves, 3 halves. So our answer here is 3 halves. We know 3 halves is an improper fraction, and we need to write it as a mixed number. So we know that there are exactly 1 set of 2 inside of 3. And if we look, boys and girls, we see that there's these 2 fit inside of 1, and then we have 1 that's left over. And we know that this 1 that's left over is representative of a half. So Martin will plant 1.5 meters in each row. So now we're going to go on to the next part, draw conclusions. It says, explain why you placed 4 fraction strips with the same denominator under the 2 one-whole strips. So what we would say is, I wanted to divide the entire length of the 2 holes into 4 equal pieces. And 4 half strips did that. So now next, boys and girls, it says, explain how you would model 3/10 of 2. So what I'm going to do is I'm going to draw this out again for you like we did in the last. So we have 2 holes, 1 hole, 2 holes. And now if we want to represent 3/10, when we look at the denominator, we see that the denominator says 10. So we need to figure out what would allow us to have 10 pieces on here. If you thought of the answer of fifths, boys and girls, that would be exactly correct. We need to have fifths under here, because if we have 1/5, 2/5, 3/5, 4/5, 5/5, 1/5, 2/5, 3/5, 4/5, 5/5, let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of these little pieces represent 1/5. 5 plus 5 would be 10. So if we were to model 3/10, we would circle 3 of the 10 that we have. And because we know that each of these represents 1/5, we would say that would be 1/5 plus 1/5 plus 1/5, which would give us 3/5. So whenever you have to explain, boys and girls, make sure you make the drawing first. So let's explain our drawing. We would say, I would show 2 holes, and then place 10 1/5 fraction strips under the 2 holes to show 10 parts. I can draw my model and circle 3/10 of 2, which is 3/5. So now, boys and girls, we're going to go on to a different type of problem. And the first problem we did a fraction by a whole number multiplication, but now we're going to do a whole number by a fraction. So we're starting with our make connections. In the investigate, you multiplied a whole number by a fraction. You can also use a model to multiply a fraction by a whole number. So the commutative property of multiplication allows us to change the factors, boys and girls, and not affect the answer. So it says Margot was helping clean up after a class party. There were 3 boxes remaining with pizza in them. Each box had 3/8 of pizza left. How much pizza was left in all? So we're going to use our fraction circles this time. And remember, boys and girls, 1 fraction circle is equivalent to 1 red fraction tile. Just to keep that in your mind. We're just using a different model in this example. So step 1, it says find 3 times 3/8. Model 3 1-whole fraction circles to represent the number of boxes containing pizza. So, boys and girls, we're going to do that. Each box has 3/8 in it. So it says place 1/8 fraction circle pieces on each to represent the amount of pizza that was left in the box. Shade the fraction circles below to show your model. So this would be 1/8, 2/8, 3/8. 1/8, 2/8, 3/8. 1/8, 2/8, 3/8. And remember, boys and girls, it's 3 times 3/8. So what we have to do is we have to show that in all to represent our answer. So now in step, what we should do next is we should count up all our 8s. So we have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8. Our answer would be 9/8, but that's an improper fraction. What we're going to do is we're going to say how many sets of 8 are inside of 9. We'd say that there are 8/8. So if we take out one of those 8/8, we could trade it for a whole, and then we would have 1/8 left over. Remember, 8/8 is equivalent to saying 1. What we're going to do is we're going to now count. Each circle here had 3/8 of a whole. So let's write that in there. Each circle had 3/8 of a whole, and the 3 circles show 9/8, and we counted them up. We had 3, 6, 9. So now it says complete the number sets. 3/8 plus 3/8 plus 3/8 would give us 9/8, or like we said, 1 whole and 1/8 left over. So 3 times 3/8 would be 1 and 1/8. So Margot had 1 and 1/8 boxes of pizza left. So I'm going to go through and do one common misconception that some students might have when doing these problems. And I'm going to write this problem up here, and we're going to explore this together. So in this common error, which I want to write on the side just to keep everybody in check to make sure that they understand what we're looking at, we see that this student modeled 3 sets of 1/3. And when they were asked to circle the answer, they only circled the last 2 thirds of the 3. So students may incorrectly sometimes circle 2/3 of 1. If we look at this, we know that if we trade 3/3 in, we would get 1 whole. So it's not, this is the answer for technically 2/3 times 1, which would give us 2/3. We know that too because of the identity of multiplication property. So what the student should have done was, what they should have done is they should have modeled 3 wholes, 1 whole, 2 whole, 3 wholes, and then they're going to represent what fraction strip would fit exactly under the 3 wholes. That would give us 3 pieces. So, boys and girls, as you can see, when you're modeling fractions and you're modeling multiplying fraction by a whole number, the student should have multiplied 3 wholes and then underneath it multiplied thirds. So we see that we have 3 wholes times 2/3. What we would do is we would count out. Sorry about that, boys and girls. I was just modeling the next problem actually from the homework. But as you can see that when you're modeling out fractions, you have to multiply out the whole, and then underneath it, you're placing what fraction strips fit exactly underneath the wholes, or the 3 wholes or the 2 wholes.